Welcome to today's session. So we continue looking at differential equation. Our question of interest is solve dy dx equals ky, where k is a constant. So what we know basically is we are saying change in y as a result of change in x is equal to a constant and change in y, which is the dependent variable. So this side, this is over 1, basically it's the same as over 1. The first step is to cross multiply. 1 multiplied by dy, then this one multiplied by that. So what we get basically 1 dy is equal to k dx. The next step is to divide by y both sides so that we get rid of y as a product of dx. Then we end up with nothing but 1 over y dy is equal to k dx. So at this point is for us to introduce the integration. So to introduce the integration, we are integrating 1 over y with respect to y is equal to a constant outside 1 with respect to x. Then the next step is do the actual integration. So the question that you're asking us is for us to get 1 over y, what function did we differentiate? So basically we should have differentiated a natural log of an absolute value of y plus a constant is equal to, then this side, what function do you differentiate for us to get a 1? We differentiate with respect to x. So we should have differentiated the x itself plus a constant, because a change in the constant is 0. Then at this point, we collect the like term. What we notice is we only have natural log of an absolute value of y is equal to k times x plus a constant. Because once c1 crosses the other side, it will be c2 minus a constant, which will still give us an arbitrary constant. Nothing else changes. Then the next step is to make y the subject of a formula. So we know that y is a natural log. So we need to find an inverse of a natural log, which is an exponential. So introduce an exponential this side. So an exponential of a natural log of y, exponential to the power natural log of y is equal to exponential to the power kx, then plus c. So we know that in exponential, when you have a plus, basically it means multiplication. So this tells us, we know that to the left hand side, this gives us nothing other than an absolute value of y is equal to exponential to the power kx multiplied by exponential to the power c. Now we know that c is nothing other than exponential to the power c because it's a constant. So what we get is basically an absolute value of y is equal to a constant c multiplied by an exponential to the power kx. Then, since we are dealing with an exponential which can take a negative power or a negative number, we remove the restriction on y. So we end up with y is equal to a constant c multiplied by an exponential to the power kx. So this basically gives us the answer we are looking for. So this is the final answer. So we are coming from integrate this function by saying solve this differential equation, then we end up with y is equal to c multiplied by an exponential to the power kx.